Today we're going to talk about section 5.3. We're continuing with trigonometry. These are the other trig functions. So let's review where we were. Okay? If we have a unit circle, then this point would be 1, 0. This would be the point 0, 1. And for any angle that we cut off, we'll call it alpha, it will intersect the circle at the point x over y, or x over y, x comma y. This might be easier to see so this is a radius of 1. Because we could drop an altitude here, and then we would form a triangle, like so. So if I pull that triangle out, it will be a right triangle. The hypotenuse is a length of 1. Here's the point x comma y, where it cuts the circle. Then the length of this side must be x, and this side must be y. Here's our angle alpha. And some of you remember SOHCAHTOA from our high school geometry classes, trigonometry classes, okay? Where this means that the sine of this case of the angle, in our case it's alpha, is equal to the opposite over the hypotenuse, which is just 1, which is by definition what we said sine was yesterday. Then the cosine of alpha is the adjacent over the hypotenuse. And the side that's adjacent to our angle alpha is x over the hypotenuse, which is simply just x. So yesterday when we were just reading around the unit circle for our coordinates to find the cosine, the sine and the cosine. No, the cosine and the sine. This is how we could do it. There is another function, it's called the tangent of alpha. And that is defined to be the opposite, which is y, over the adjacent, which is x. So these are our three main trig functions. Okay. Now there are also the reciprocal functions. These are known as the cosecant, which we abbreviate CSC, and it is the reciprocal of this. So instead of y over 1, it's 1 over y. Then we also have the secant of alpha, which is the reciprocal 1 over x. And the cotangent, which is the reciprocal x over y. So these are just the names of the reciprocals. Okay. Now that leads us to a few identities that we know to be true. Okay, so identities are going to be true for any angle that we put in. So if the tangent of alpha is defined to be y over x, well, y is the sine of alpha, and x is the cosine of alpha. So the tangent, if we have the tangent of alpha, we could always write it as the sine of alpha over the cosine of alpha. Similarly with the cotangent, since it's a reciprocal, the cotangent of alpha could be written as the cosine of alpha over the sine of alpha. Okay. We're going to be building a lot of identities, so you might want to get flashcards started with these. Now the secant of alpha, the secant is the reciprocal of cosine, so we could always write that as 1 over the cosine of alpha. And similarly, the cosecant of alpha, we could always write as the reciprocal 1 over the sine of alpha. Okay. So these are some identities that we'll need. Now let's see if we can find some of these values for the other trig functions. So, for example, let's say we needed to find the tangent of 4 pi over 3. Well, we know that that's going to be the sine of 4 pi over 3 over the cosine of 4 pi over 3. So now we just have to remember where on our unit circle that falls. Okay. Now 4 pi is over 3 is the same thing as 8 pi is over 6. Okay. So this is 3 pi over 2, which is 9 pi over 6. This was 6 pi over 6. Okay. So 8 pi over 6 falls here. Okay. So if we were to build the triangle, to get there I would go the short direction in the x and then the long direction in the y. Okay. So this is the point negative 1/2, comma, negative square roots of 3 over 2. Okay. Where this is the cosine and this is the sine. So from here, then the sine of 4 pi over 3 is negative square roots of 3 over 2. And we divide that by the cosine, which is negative 1/2. And then we can just simplify. Okay. The negative and the negative become positive. And then we can take this one, and we're dividing fractions, so to do that we'll invert and multiply. Then these will cancel, and we're left with the square root of 3. Here's another. Let's find the secant of 150 degrees. Well, the secant is 1 over the cosine of 150 degrees. Okay, so we can automatically write that. And then let's determine where that's at on the unit circle. Okay, so if this is 180 degrees, here's 150. So to get there, we would need to come out the long side of the circle and then up the short side. So the long side first, and then the short side. So there's our triangle. So this is the point negative square roots of 3 over 2 and positive 1/2. So this is equal to 1 over the cosine of 150 degrees. Well, the cosine of 150 degrees is negative square roots of 3 over 2. And then we'll want to simplify. Remember, we could write 1 as 1 over 1. So when we multiply, we'd be taking the reciprocal, and this would become negative 2 over the square roots of 3. We've just moved the negative up top. 1 times anything is 1. It's itself. Now we need to rationalize this denominator. So up top we have negative 2 square roots of 3. And down below, square root of 3 and square root of 3 is just 3. Okay? So this is the exact value of the secant of 150 degrees. So that's how we do it. Now, we could also be given a point on the circle. And we would do the same thing. So let's say we were given this point on the unit circle, negative square roots of 3 over 2, comma 1/2. We know this belongs to 150 degrees, or 5 pi over 6. But even if we didn't know that, if we were given this point, we could find all of the trig functions. Okay. So I like to set it up, what should we call this? Theta? Okay. So we'll know that the sine of theta, and then I do the cosine of theta, and then the tangent of theta. And then I write in the reciprocals. So the tangent, it's very easy to remember that the cotangent goes with that. Then from here, I have to think, is it the secant or is it the cosecant? So I always look here. This C doesn't match with this T. And it's true with the other ones as well. So if I have a C here, I don't want to put the cosecant, I want to put the secant, because they don't match. And then with the sine, I would put the cosecant, because they don't match. Okay? So that's how I remember how it goes. Okay, let's fill it in. Okay, so the sine is the y value, so that's 1/2, which means its reciprocal is just 2. The cosine is negative square roots of 3 over 2. So the secant is its reciprocal, which is negative 2 over square roots of 3. But we'll rationalize, and as we just saw in the last example, that's negative 2 square roots of 3 over 3. Now the tangent's going to take a little bit more work. That's sine over cosine, which is 1/2 divided by negative square roots of 3 over 2. Okay. So there's a negative here, and I need to bring that up. Okay. Now let's just do some scratch work here. 1/2 divided by negative square roots of 3 over 2 is the same thing as multiplying by negative 2 over the square root of 3. Yeah. The 2's will cancel, and we have 1 over the square root of 3. That's what we're left with. But we'll rationalize that to get negative square roots of 3 over 3. That's our tangent's value. Okay, I could take the reciprocal of this for the cotangent, so that's negative 3 over square roots of 3. Again, we rationalize. This becomes negative 3 square roots of 3 over 3, and those will cancel, leaving just negative square roots of 3. Okay. So these are our 6 trig functions if we're just given the points. So there's questions like that. If you're given the point, determine the 6 trig functions. They might also say, give you an angle, and then ask you to find the 6 trig functions. So if it was pi over 6, we'd know it's here. First thing you do is identify, this would be the long side, so square roots of 3 over 2, and then this would be the short side. And then go through this process that we did again, and you can find all 6 trig functions. And I guess let's start with this example. Okay, so we could have the sine here of, let's call this one alpha. Well, yeah, okay, that's fine. Sine of alpha is 1/2. Okay. The cosine of alpha is square roots of 3 over 2. And then using the same reasoning here, we would just get now the positive square roots of 3 over 3. Okay. So we might ask ourselves about the even and oddness of this function. Here we have symmetry across the circle. So let's remember about even and odd functions. Okay. Now, by definition, a function is said to be even if, when you take the original function and evaluate it at negative x, you get the original function back. And in terms of the trig functions, the cosine of alpha is even. Well, why would that be? Let's look again at pi over 6. We saw that that was square roots of 3 over 2 and 1/2. We could also look at negative pi over 6, and this is square roots of 3 over 2, comma, negative 1/2. Okay, so this is the cosine and this is the sine. This is the cosine and this is the sine. So we're going to let x from this function be pi over 6. Then the cosine of pi over 6 is equal to square roots of 3 over 2. And the cosine of the negative angle, negative pi over 6, is also square roots of 3 over 2. So in this way, f of negative x is equal to f of x. So therefore, cosine of alpha, your angle, is even. Now, if a function is odd, remember when you take the negative angle, what you'll get is the opposite of the original. So again, we'll let x equal pi over 6. And we know that the sine of the positive angle, pi over 6, well, that's here. That's 1/2. We could look at the sine of the negative angle, and we come down here, and that's equal to negative 1/2, which is the opposite of the sine of the positive angle. Then we can say, so f of negative x is equal to negative f of x, and therefore sine of x, alpha, is odd. And as a direct result, because tangent is sine over cosine, we have odd over even. We'll also get that tangent is odd. So that'll be helpful for us when we're simplifying things. So let's think about this. If we have the secant of alpha is equal to 2, what is the secant of negative alpha? Well, let's think about this. Okay. We know that the secant of alpha is 1 over the cosine of alpha. And that the secant of negative alpha would have to be the 1 over the cosine of negative alpha. But it turns out these two are equal because the cosine of alpha is equal to the cosine of negative alpha. Because cosine is even. So that would mean that it has to be, there's equality, so the secant of negative alpha is also 2. Okay, so that's how you're going to do anything like this. If you're given one of these functions and asked to find the opposite angle, first turn it into sines or cosines, and then evaluate cosine and sine in terms of being even and odd before you come up with your answer. Okay, so we have those identities. Okay, also remember, let's do some more identities. Okay. Remember in our unit circle, this is 1, 0. This is 0, 1. Okay. The equation of this circle is x squared plus y squared equals 1. And then we have the trig form of that, where the x value is the cosine, so we wrote that cosine squared of x plus the y squared is sine squared of x is equal to 1, or alpha or theta, whatever value you want to put in there. Okay? And this was our fundamental identity. But there are also different forms now that we know about the tangents. So this is our first form. But let's say I had tangent squareds. I might be concerned about tangent squareds. Well, I have a sine squared. So if I divide that by cosine squared, this would reduce to tangent squared. But I can't just do that for one. I have to do them for all. If I'm going to divide by cosine, I need to divide through by cosine squared and everything. So this becomes 1. We'll keep the plus. And 1 over cosine is secant. So this becomes secant squared. So this is our second form. This one I don't memorize. You can either choose to memorize it or you can choose to learn how to get to it. I always just choose to learn how to get to it. Okay. Let me rewrite this. There's another thing we could do. Let's pretend now that we didn't want to divide by cosine squared, but we could also divide by sine squared. When we do that, now instead of sine over cosine, we have cosine over sine, which is cotangent, and then we square it of x. That's this. Sine squared over sine squared is 1, and 1 over sine squared is cosecant squared of x. So this is our third form. And that will be helpful for us in the future. Okay, let's do an example where this might be helpful for us. Okay, so for example, let's say that we have the cosine of x is equal to 12 over 13. And we'll say that x is in 4. Okay. So if I was to sketch that on a unit circle, if I'm in 4, then the cosine would come out here to about 12 over 13. And so I would get to some point 12 over 13 comma y. I don't know what it is because it's not on one of our known angles on the unit circle. But I can find out what y is because I know that cosine squared of x plus sine squared of x has to equal 1. And I also know what the cosine is. So that's 12 over 13. If I square that, now this is an equation that I could solve for. Okay. Right. So this is 144 over 169 plus sine squared of x is equal to 1. I'm going to subtract 144 over 169. And let's rewrite 1 as 169 over 169. So sine squared is equal to 25 over 169. Now I can take the square root of both sides to get sine of x is equal to plus or minus. And let's split this up. 25 is a perfect root, and so is 169. So we have that the sine of x is equal to 5 over 13 plus or minus. Now we're on a unit circle, so the sine value that we pick here will be the y value that we're looking for. Okay. But which is it now? Is the sine positive or is the sine negative? Which one do we pick? And for that we have to come back and realize that we are in quadrant 4. So if you're in quadrant 4, this has to be negative. So we're picking the negative branch because of the quadrant that we were told. Okay, I'm just looking to make sure, looking at your homework to see what else we might need to talk about, but I think that will get you through everything. Remember the even and oddness and how to find the 6 trig functions. So an even and odd, just rewrite whatever you're given in terms of sines and cosines and use their even and oddness. And these are some identities that we need to get memorized or figure out how to do them, to write them. Other than that, the basic questions are how to evaluate these trig functions. I hope you know your unit circle. That will make things much easier to deal with. Okay. That should do it. Email me if you have any questions.